Consider this: what if everything you've ever known about the universe is just the tip of the iceberg? Imagine the universe not as just a collection of stars and planets, but as a vast, ever-expanding canvas of mysteries waiting to be uncovered. Over the next few moments, we're about to embark on a journey that will shatter your perceptions and unveil 25 astonishing truths about the universe that will challenge even the most skeptical minds. From the mind-bending ideas of multiverses to the eerie quiet of cosmic voids, each revelation promises to be more extraordinary than the last. As we venture into this cosmic exploration, prepare to see the universe in a way you never believed possible. So buckle up, because by the end of our journey together, you'll not only marvel at the wonder of these revelations, but you'll also question everything you thought you knew. Are you ready to embark on a quest that will redefine your understanding of the cosmos? Let's dive into the celestial unknown. The universe is expanding faster than light. Let that sink in for a moment. This isn't science fiction, but a mind-boggling reality that challenges everything we think we know about space. So how is it possible for the universe to expand at such a blistering pace, and what does this mean for us? The secret lies in something called dark energy. Imagine it as a mysterious force permeating every corner of space, gently yet relentlessly pushing the universe to stretch further and faster. It's as if the universe has its foot on the accelerator pedal with no sign of slowing down. Dark energy, although invisible and undetectable directly, makes up about 70% of the universe's total energy content. Its influence is so profound that it counteracts the gravitational pull of galaxies, which would otherwise slow the expansion down. The implications of this cosmic acceleration are staggering. Over time, galaxies will drift further apart, making some of them permanently unobservable from our vantage point on Earth. This means that future astronomers might see a universe very different from the one we observe today, with vast regions of emptiness replacing the rich tapestry of galaxies. As we grapple with the concept of an ever-expanding universe, we're forced to reconsider our place in the cosmos, understanding that while we are part of something infinitely larger, we also inhabit just one tiny corner of a vast and mysterious expanse. The universe's rapid expansion prompts profound questions about the ultimate fate of everything we know, leaving us to wonder how this mysterious force continues to shape the cosmos around us. We are made of star stuff. It's not just a poetic notion, but a profound truth that ties us inherently to the cosmos. The very elements that form our bodies, from the iron in our blood to the calcium in our bones, were birthed in the heart of stars. So how exactly does this cosmic alchemy occur? Through a process known as stellar nucleosynthesis. Stars are like immense nuclear furnaces, where lighter elements like hydrogen and helium fuse under immense heat and pressure to form heavier elements. Imagine a star as a colossal kitchen, cooking up the ingredients that make up everything we see around us. As stars age, they create even more complex elements in their fiery cores. Eventually, when stars reach the end of their life cycle, they often explode in spectacular supernova, scattering these elements across the galaxy. This stardust becomes part of the cosmic recycling process, condensing into new stars, planets, and ultimately, life. It's humbling to realize that every single atom in your body was created billions of years ago in a star that once shone brightly across the universe. The next time you gaze at the night sky, remember that the light you see isn't just illuminating the heavens, it's a reminder of our shared stellar heritage. The universe is not something out there but within us, connecting all living things in a grand cosmic tapestry. Each breath we take is a testament to the universe's creativity and its endlessly unfolding drama. This interconnectedness makes us not just inhabitants of the universe but intrinsic parts of it, woven into the very fabric of existence. Cosmic microwave background radiation, or the CMB, is like the afterglow of the universe's birth. Imagine this radiation as the gentle hum of an ancient cosmic symphony, still echoing across the cosmos from a time when the universe was just a newborn. This faint light carries secrets that reach back over 13 billion years, offering a glimpse into the universe's infancy just a few 100,000 years after the Big Bang. Picture the universe back then as an incredibly hot and dense soup of particles, light and sound. As it expanded and cooled, atoms began to form and the cosmos became transparent. This was the moment when the CMB light was set free to travel through space. Fast forward to today, and this light has stretched into microwave wavelengths due to the universe's expansion, a process we call redshift. The CMB is like a cosmic time capsule, preserving the conditions of the early universe. It has allowed scientists to map and study the universe's structure, revealing tiny fluctuations in temperature that correspond to the seeds of stars and galaxies. These fluctuations provide a blueprint for the universe's evolution and have led to discoveries that confirm the Big Bang theory as the best explanation for our cosmic origins. By studying the CMB, we gain unmatched insights into fundamental questions about the universe's composition and dynamics. This relic radiation is more than just an ancient echo. It is a crucial tool that helps us unlock the mysteries of the universe's earliest moments, allowing us to understand how everything we see today came into being. As we delve deeper into the cosmos, the CMB continues to light our way, guiding us through the wonders of the universe's past and fueling our curiosity to uncover its many secrets. Most of the universe is invisible. That's right, the vast majority of what makes up the cosmos is something we can't see, touch, or directly detect. This invisible substance comes in two forms: dark matter and dark energy. Imagine them as the unseen architects of the universe, quietly and profoundly shaping everything around us. Dark matter, making up about 27% of the universe, acts like a cosmic scaffold. Think of it as the invisible web holding galaxies together, affecting their shape and movement. Although it doesn't emit or absorb light, we know dark matter exists because of its gravitational effects on visible matter. It's like watching the wind rustle leaves. You can't see the wind, but you know it's there. Meanwhile, dark energy, accounting for roughly 68% of the universe, is even more mysterious. Picture it as a force driving the universe's accelerated expansion. It's the engine behind the universe's cosmic sprint, counterbalancing gravity and pushing galaxies apart at an ever-increasing pace. Together, dark matter and dark energy comprise the majority of the universe's mass-energy composition, leaving a mere 5% to the familiar atoms and particles that make up stars, planets, and life as we know it. Understanding these enigmatic forces is one of the greatest challenges and frontiers of modern physics, pushing our knowledge to new limits. As we delve further into the mysteries of dark matter and dark energy, we inch closer to unveiling the universe's greatest secrets, expanding our understanding of the cosmos and our place within it. Black holes aren't always black. These cosmic giants, typically seen as voids from which nothing can escape, have secrets hidden beyond their ominous facade. Imagine a black hole as a monster in the night, seemingly swallowing everything. But here's the twist: they're not the absolute darkness we once believed. Thanks to the groundbreaking work of physicist Stephen Hawking, we now understand that black holes can emit energy, a phenomenon known as Hawking radiation. This occurs because of quantum effects near the event horizon, where particle-antiparticle pairs come into existence. Visualize it as a cosmic dance at the edge of doom, where one particle escapes as radiation while its twin is consumed by the black hole. This energy emission means that black holes can slowly lose mass and eventually evaporate over astronomical timescales. It challenges our understanding of these mysterious entities and suggests that they might one day vanish completely. The existence of Hawking radiation not only reshapes how we view black holes, but also ignites new questions about the battle between gravity and quantum mechanics. As we continue to explore the universe, the enigma of black holes reminds us that our cosmic knowledge is ever evolving, filled with surprises that challenge our perception of the universe's dark corners. The universe might be infinite. Ponder that for a moment. Imagine the cosmos stretching beyond any boundary, an endless expanse where every new horizon leads to another and another without ever reaching an edge. This mind-bending possibility challenges our understanding of space and infinity. So what would it mean if the universe is truly infinite? For starters, it could imply that there are infinite versions of everything, including infinite variations of our own world, where every possible outcome of every event occurs in some distant corner of the universe. Theories in cosmology, such as eternal inflation, suggest that the universe expands forever like an unending balloon, creating an infinite patchwork of cosmic regions, each with its own distinct laws of physics. In this scenario, the multiverse concept gains intrigue, proposing that our universe is but one among countless others, each part of an infinite cosmic ocean. An infinite universe raises profound philosophical questions as well. If space is boundless, then every imaginable reality might exist somewhere. Picture the idea that there are galaxies exactly like ours, with planets like Earth, and maybe even other beings wondering if the universe is infinite too. This concept of infinity pushes the boundaries of our imagination and challenges our place in the grand scheme. As we continue to explore and study the universe, we find ourselves inching closer to understanding whether this infinite possibility is reality or simply a tantalizing theory. Yet, whether the universe is truly infinite or not, it inspires us to explore, question, and marvel at the endless possibilities that stretch out into the unknown. This exploration enriches our perspective, fueling our curiosity and our desire to uncover the secrets of the cosmos. The concept of multiverse theories is both dazzling and divisive. Imagine our universe as merely a single page in an infinite book of universes, each page representing a different universe with its unique rules and realities. This idea opens up an entire world of possibilities and raises intriguing questions. How could this work? One theory suggests that just after the Big Bang, our universe began to expand and inflate rapidly, leading not just to the creation of our own universe, but possibly countless others in an ever-expanding cosmos. Each of these universes might have different physical laws, varying constants, and diverse cosmic events. It's like a gigantic cosmic lottery where every possible outcome happens somewhere. Another fascinating framework is the concept of parallel universes, where every decision you make creates a new universe where a different choice was made. Picture countless versions of yourself living out numerous alternate realities. While these ideas may sound like the stuff of science fiction, they are serious topics of discussion in the field of cosmology. Although we currently lack direct evidence for the multiverse's existence, the implications are profound. The multiverse theory could help explain some of the mysteries of our universe, like the fine-tuning of physical constants that make life possible. If there are infinite universes, then in some, those constants might not be suitable for life at all. Yet in ours, they are just right. As we delve deeper into these intriguing possibilities, we're reminded that our understanding of the cosmos is constantly evolving. The notion of a multiverse encourages us to look beyond our universe with wonder and reconsider our place within a potentially vast and varied cosmic expanse. These theories challenge our conventional views, inviting us to ponder realities beyond our own and inspiring endless curiosity about what exists beyond the visible universe. The observable universe is just a fraction of a much grander cosmos. Imagine our universe as a tiny island in a vast ocean, where much of the universe's true brilliance remains beyond our sight. The concept of the observable universe is based on the limitations of how far light has traveled since the universe's birth about 13.8 billion years ago. Because light takes time to reach us, we can only see objects as they were when their light first started its journey toward Earth. This means there are regions beyond our observable universe that we will never see, simply because their light hasn't had enough time to reach us. Now think about this. The universe itself is expanding over time, and as it does, more light from these distant regions will never reach us, creating a cosmic horizon beyond which lies a universe we cannot observe. This cosmic horizon marks the boundary of our observable universe, a limit not in space itself but in our ability to witness it. In essence, the universe is like a colossal blank canvas with only a small corner painted with the scenes we can explore. The mysteries lying beyond this horizon are profound and tantalizing, filled with possibilities that stretch our imagination. They challenge our understanding and invite us to consider how little we truly know about the universe's total expanse. As scientists attempt to unravel more about what's out there, the boundless nature of the universe continues to inspire awe. Each new discovery serves as a reminder that in the grand tapestry of the cosmos, much remains hidden, waiting to be unveiled. The observable universe might be just a fraction of the whole, but it sparks boundless curiosity and fuels our quest to explore what lies beyond the limits of our sight. Time dilation in space is a concept that almost seems like science fiction, but is rooted in the very fabric of our universe. According to Einstein's theory of general relativity, time doesn't tick the same for everyone everywhere. Imagine this: if you were to travel near a massive object like a black hole, time for you would slow down compared to someone far away from that object. It's as if the universe has its own time zones, dictated not by lines on a map but by the warping of space-time itself. The stronger the gravitational pull, the slower time moves. Picture an astronaut venturing close to a black hole, where hours might pass for them while decades roll by in the outside universe. This isn't just a theoretical concept either. It's been observed in satellites orbiting Earth, where time deviates just a tiny bit due to our planet's gravity. These small variations might not disrupt our daily lives, but they are vital for the accuracy of GPS systems we rely on every day. In the vast and mysterious reaches of space, time dilation reveals that time is more fluid and relative than we ever imagined. It challenges our perception of reality and hints at a universe where time can stretch and bend, leading to futures where the passage of years might vary drastically depending on where you are in the cosmos. As we continue to explore the universe, this phenomenon not only fascinates scientists but also fuels our curiosity about the nature of reality itself. Each revelation about time dilation nudges us closer to understanding the true complexity of our universe, reminding us that space, time, and gravity are intertwined in the cosmic dance that governs everything we know. The most powerful explosions in the universe are truly awe-inspiring cosmic events. Imagine explosions so intense that they outshine entire galaxies for brief moments. We're talking about gamma-ray bursts and supernova. Gamma-ray bursts are the universe's most intense radiation emissions, releasing in a few seconds more energy than the sun will in its entire lifetime. Picture a beam of extreme radiation shooting out from a collapsing star at nearly the speed of light, capable of affecting entire galaxies despite being billions of light years away. These bursts are thought to occur when massive stars reach the end of their life cycles and collapse into black holes, releasing colossal energy jets. Then there are supernova, the spectacular death throes of stars. Imagine a star running out of fuel, leading to a catastrophic collapse and a phenomenal explosion that flings the star's outer layers into space. Supernova are not just dazzling displays of power, they are crucial to cosmic evolution. They scatter elements throughout space that are essential for forming new stars, planets, and even life. These explosions create shock waves that compress surrounding gas, triggering the birth of new stars and shaping entire galaxies. Both gamma-ray bursts and supernovas serve as reminders of the universe's dynamic and interconnected nature. They illustrate the cycle of death and rebirth, where the end of one star's life can sow the seeds for new stars and new beginnings. As we observe these colossal cosmic fireworks, we're given a glimpse into the incredible forces that sculpt the universe, revealing the profound and sometimes violent beauty of the cosmos. The truth is, planets aren't exclusive to solar systems. Imagine planets adrift in the vastness of space, unbound by the gravity of a star. These are rogue planets wandering the galaxy like cosmic nomads. Without a sun to orbit, they float freely through the interstellar void, drifting through the galaxy without a home. So what makes rogue planets so intriguing? Well, for starters, they challenge our traditional understanding of how planets exist within solar systems. Unlike the planets in our solar system that revolve around the sun, rogue planets roam independently, following their own unique path. Despite this isolation, these wandering worlds might still hold the potential for life. Some scientists speculate that rogue planets could maintain liquid water beneath thick ice layers, warmed by geothermal energy from their interiors. This internal heat could create a haven for life in the dark, sheltered from the frigid temperatures of space. The discovery of rogue planets opens up new possibilities for understanding planetary formation and the conditions necessary for life. As we learn more about these cosmic roamers, we may uncover secrets about the universe's creativity in forming planets, showing us that life may thrive in even the most unlikely places. By studying rogue planets, we expand our vision of where life could exist, moving beyond the confines of traditional solar systems and venturing into the unknown. These free-floating planets remind us that the universe is full of surprises, sparking our imagination about the many forms and places life might inhabit. As we continue to search the stars, rogue planets remain one of the tantalizing mysteries that urge us to look deeper into the cosmos and contemplate the diversity of life across the universe. Galaxies collide, yet stars within them rarely do. Think of this paradox for a moment. Galaxies are vast systems made up of billions or even trillions of stars, gas and dust, all gravitationally bound together. Imagine two of these colossal entities on a cosmic collision course, drawn together by their mutual gravity. As they approach, their shapes begin to distort and intertwine, creating breathtaking cosmic dance patterns across the universe. But here's the fascinating part. Even as galaxies merge and clash in these dramatic encounters, the stars within them mostly continue their cosmic journey unaffected. How can this be? The explanation lies in the sheer scale and spacing of stars within galaxies. Picture a star as a tiny speck of dust in the vast reaches of space. There is so much distance between individual stars that even when galaxies collide, stars simply pass by each other like ships in the night, thanks to the wide gaps separating them. These galactic interactions are more about gravitational forces than actual physical contact. Instead of stars crashing into one another, their orbits might shift, and vast clouds of gas and dust may be compressed, often igniting star formation in the process. This can lead to the birth of entirely new stars and can dramatically alter the appearance and structure of the merging galaxies. So while the sight of colliding galaxies is a spectacular event in the universe, the rarity of star collisions within them highlights the remarkable emptiness and scale of space. As we observe these grand cosmic ballets, we're reminded of the delicate balance and serenity that can exist amid chaos, a testament to the universe's incredible vastness and symmetry. Each collision is a reminder of the dynamic and interconnected nature of the cosmos as galaxies evolve and reshape over millions of years, enriching our understanding of how the universe changes and grows. The universe is mostly hydrogen. Picture this for a moment. If the cosmos was a recipe, hydrogen would be the main ingredient, making up nearly 75% of the universe's elemental composition. But why is hydrogen so abundant? It all began in the early moments after the Big Bang. During this intense and hot birth of the universe, particles collided at incredible speeds, forming protons and neutrons. As the universe expanded and cooled, these protons and neutrons combined to form the simplest element, hydrogen. This process, known as Big Bang nucleosynthesis, set the stage for the hydrogen-rich universe we see today. Hydrogen's simplicity is its strength. Being the lightest element, it's incredibly versatile and able to form under a wide range of cosmic conditions. This abundance allowed the first stars to ignite as clouds of hydrogen gas collapsed under gravity, heating up and eventually triggering nuclear fusion. As stars formed, they acted like cosmic factories, creating other elements and scattering them into space through supernova explosions. Despite these cosmic alchemical feats, hydrogen remains the foundational building block of stars and galaxies, fueling their formation and evolution. Its abundance allows for the continued birth and death of stars, a cycle that shapes the structure of the universe. The prevalence of hydrogen underscores its critical role in the cosmos, showing us that even the simplest element can be a powerhouse of cosmic creation. As we continue to peer into the depths of the universe, hydrogen's presence reminds us of the universe's fascinating origins and its ongoing dance of creation and transformation. Neutron stars are incredibly dense, and their properties are nothing short of extraordinary. Imagine a star packing more mass than our Sun into a sphere only about 10 miles wide. This makes neutron stars some of the densest objects known in the universe. It's like squeezing a mountain into a teaspoon, but what makes them so dense? When massive stars exhaust their nuclear fuel, they can explode in a supernova, leaving behind a core that collapses under its own gravity. This core becomes so compact that protons and electrons merge to form neutrons, resulting in a neutron star. These stars boast intense gravitational fields that are so strong, a teaspoon of neutron star material would weigh as much as a mountain on Earth. The gravity is so powerful it can warp space-time around the star, influencing everything nearby. But gravity isn't the only force at play. Neutron stars are also known for their staggering magnetic fields, trillions of times stronger than Earth. These magnetic forces can accelerate particles to incredible speeds, producing beams of radiation that sweep across space like cosmic lighthouses. These beams can be detected as pulsars if they point toward Earth, giving us insights into the universe's most extreme conditions. The exotic nature of neutron stars challenges our understanding of physics, pushing the boundaries of what we know about matter and energy. Their density and forces offer a glimpse into the universe's most dramatic processes, reminding us that even in death, stars can give birth to some of the most intriguing and mind-boggling entities in the cosmos. As we continue our exploration, neutron stars will undoubtedly remain a captivating subject, revealing the wonders of the universe's endless capacity for surprise. There are more stars than grains of sand. This astonishing fact gives us a glimpse into the sheer scale of the universe. Imagine standing on a beach, each grain of sand slipping through your fingers. Now consider that all the beaches and deserts on Earth couldn't begin to match the number of stars in the sky. Astronomers estimate there are over 100 sextillion stars in the observable universe. That's a 1 followed by 21 zeros. To put that into perspective, think of every single grain of sand on every beach and desert across the globe. Each handful, each beach, represents a tiny fraction of the vast cosmos filled with stars. This staggering number underscores not only the enormity of the universe, but also our relatively small place within it. It's a humbling thought, knowing that every star could potentially host planets, each with its own mysteries waiting to be discovered. The universe, it seems, is a treasure trove of endless possibilities. As we ponder these stars, we're reminded of the incredible diversity and richness of the cosmos, sparking our curiosity and inspiring us to explore further, to seek out new worlds and learn more about the boundless universe we inhabit. This comparison to grains of sand highlights the extraordinary scale and beauty of our universe, encouraging us to look up and marvel at the cosmic tapestry above us. Cosmic voids and superclusters are like the universe's grand architects, crafting its vast and wondrous structure. Imagine the universe as a spiderweb with delicate threads of galaxies forming intricate patterns across an otherwise empty canvas. These threads are the superclusters, enormous groups of galaxies bound together by gravity, while the spaces between them are the cosmic voids, vast expanses nearly devoid of galaxies. Daydream about these cosmic voids as the universe's open fields, stretching for millions of light years, where only the faintest whisper of galaxy dust can be found. They are among the largest structures ever discovered, dwarfing even our imagination. It's as if the universe is balancing its cosmic dance, alternating between densely packed regions and tranquil, empty stretches. Superclusters, on the other hand, are the universe's bustling metropolises, teeming with galaxies, stars, and planets. These clusters are gravitationally linked, forming complex networks that stretch across the cosmos like highways connecting major cities. The interplay between cosmic voids and superclusters dictates the universe's large-scale structure, influencing the movement and evolution of galaxies within these vast spaces. The forces at work are not merely random but follow a cosmic blueprint set in motion by the universe's initial conditions. Studying these structures helps astronomers understand the universe's overall shape and its development over billions of years. By mapping these celestial patterns, scientists can trace the universe's history and gain insights into its future. It is a reminder that even in the silence of space, there is a dynamic and interconnected grandeur that shapes everything we see, urging us to look deeper into the cosmic web to uncover the hidden stories woven into its vast expanse. 95% of the universe is unknown. Let that sink in for a moment. It's a staggering reality that challenges our understanding of the cosmos. The vast majority of the universe is composed of dark matter and dark energy, two of the most perplexing mysteries in modern science. Dark matter, which accounts for about 27%, is the invisible backbone of the universe. Picture it as an unseen scaffolding that holds galaxies together. Although it doesn't emit light or energy, its presence is inferred through its gravitational effects on visible matter. Imagine trying to decipher a puzzle where most of the pieces are missing, yet you can see the impact they have on the surrounding parts. Then there's dark energy, the enigmatic force driving the universe's accelerated expansion. This mysterious energy accounts for roughly 68% of the universe. It's like a cosmic engine pushing galaxies apart at an ever-increasing rate, defying the pull of gravity. Together, dark matter and dark energy comprise a whopping 95% of the universe's total content, leaving only a small fraction made up of the ordinary matter we can see and touch. Scientists are continuously probing these dark components, using advanced technology and innovative experiments to unveil their secrets. Understanding them could revolutionize our comprehension of the universe's origin, structure, and ultimate fate. Yet, as we uncover more about these mysteries, we're reminded that the cosmos is filled with unknowns, urging us to look deeper and question everything we think we know. This profound lack of understanding invites us to remain curious, to push the boundaries of exploration, and to embrace the mystery that makes the universe endlessly fascinating. Supermassive black holes govern galaxies in ways that are both awe-inspiring and enigmatic. Picture these colossal entities as the cosmic puppeteers, sitting at the heart of nearly every galaxy, including our own Milky Way. But what makes these black holes truly fascinating is their staggering size, with masses that can be millions or even billions of times that of our Sun. While black holes are known for their immense gravitational pull, it's their influence over galactic dynamics that truly captivates scientists. Imagine a supermassive black hole as the engine that fuels the galaxy's activity. As material like gas and stars spirals toward the black hole's event horizon, it heats up and emits vast amounts of energy, sometimes outshining the entire galaxy. This process, known as accretion, not only illuminates the cosmos but can also drive powerful jets of particles that shoot across space at nearly the speed of light. These jets can shape and regulate the formation of stars, influencing the growth and evolution of galaxies. Moreover, the presence of a supermassive black hole affects the orbits of stars and gas clouds in its vicinity, creating a dynamic dance around the galaxy's center. This gravitational influence ensures that galaxies maintain their structure and stability over billions of years. In fact, the mass of the central black hole is closely linked to the mass of the entire galaxy, suggesting a profound connection between black holes and galactic evolution. As we delve deeper into understanding these cosmic giants, we uncover the intricate balance of forces that govern the universe's grand design. Supermassive black holes remind us that even in the darkest corners of space, there lies immense power that shapes the cosmos on a monumental scale, fueling our quest to comprehend the mysteries that govern galaxies and the universe at large. The coldest place in the universe isn't on a distant icy world or an isolated moon, but rather in space itself. Imagine a region so frigid that it defies everything we know about temperature. Enter the Boomerang Nebula. This extraordinary nebula holds the title of the coldest natural place known, with temperatures dipping just 1 degree above absolute zero. It's a cosmic refrigerator unlike any other, but what makes the Boomerang Nebula so astonishingly cold? The answer lies in its unusual formation process. Over time, the nebula has been shedding immense amounts of gas at incredible speeds, nearly 10 times faster than that of a typical star's wind. This rapid expansion causes the gas to cool swiftly, creating an incredibly cold environment. Picture it as a cosmic air conditioner, where the rapid escape of gas chills the surrounding space to extreme lows. The Boomerang Nebula is a snapshot of the dramatic conditions that nebulae can exhibit. Nebulae, often seen as beautiful glowing clouds of dust and gas, host some of the universe's most extreme environments. Within them, temperatures can range wildly from the icy chill of the Boomerang Nebula to the blazing heat of star-forming regions. These temperature extremes play a crucial role in star formation, as the gas within nebulae collapses and heats up to ignite new stars. So as you gaze into the night sky and catch a glimpse of the shimmering nebulae, remember that these celestial wonders are more than just visually stunning. They are laboratories of cosmic extremes where the coldest and hottest conditions in the universe coexist, shaping the very fabric of the cosmos. The universe's age and size discrepancy is a fascinating puzzle that challenges our understanding of cosmic distances and expansion. Imagine a universe born in a colossal explosion roughly 13.8 billion years ago, yet stretching across a vast expanse that seems far older. How can this be? The answer lies in the ever-evolving tapestry of space-time. The age of the universe, calculated through the cosmic microwave background radiation and the movement of galaxies, suggests a timeline that aligns with the rate at which the universe has been expanding since the Big Bang. However, as our methods of observing the cosmos have advanced, we've discovered seemingly contradictory evidence that the universe might be larger than its age would suggest. Picture the universe as a balloon inflating over time. The further back in time we look, the more compressed everything appears, but as we measure the actual distances of far-off galaxies, they seem farther than we anticipated. This implies that the universe has expanded more rapidly at certain times than our original calculations accounted for. Dark energy, that mysterious force accelerating the universe's expansion, adds another layer to the complexity. It acts like a cosmic wind, pushing galaxies apart at an ever-increasing rate, which means the universe is not only vast but constantly outpacing our expectations. As scientists wrestle with these observations, they're led to question fundamental aspects of cosmology, including our understanding of the universe's true size and history. This age and size discrepancy invites us to re-evaluate the very nature of cosmic expansion, pushing the boundaries of our knowledge and inspiring the pursuit of answers to the profound mysteries that shape our understanding of the universe. As we continue to probe deeper into these cosmic questions, we're reminded of the beauty and intricacy of a universe that continually challenges our perception, urging us to keep exploring the limitless expanse that lies beyond. The phenomenon of quantum fluctuations giving birth to particles is like peering into the universe's most mystical realm. Imagine an empty vacuum, a space that seems devoid of any substance. But within this emptiness lies a secret playground of quantum mechanics, where particles can spontaneously emerge and disappear. This bizarre concept is driven by the uncertainty principle, which allows particle and anti-particle pairs to briefly pop into existence before annihilating each other. Visualize it as a fleeting dance on the quantum stage, where particles are momentarily borrowed into reality, adding a dynamic layer to what we perceive as emptiness. These fluctuations are not just theoretical musings, but have real implications in the universe. They contribute to phenomena like the Casimir effect, where the energy of these particles influences the force between closely placed objects. Moreover, quantum fluctuations during the early universe are believed to have sparked the seeds for all large-scale structures we see today, such as galaxies and clusters. It's as if the universe used this quantum quirk to paint its vast cosmic landscape. By exploring these fluctuations, scientists delve into the fundamental nature of reality itself, challenging our concepts of what is and isn't, and expanding our understanding of how the universe became the wondrous expanse we observe. The very fabric of the cosmos vibrates with these quantum whispers, guiding our journey into the depths of the unknown and reminding us that even in the silence of space, the universe is alive with potential and mystery, inviting us to keep questioning and exploring. The cosmic light horizon is a captivating boundary that defines the limits of our observable universe. Imagine it as a bubble surrounding us, marking the farthest distance to which light has traveled since the universe began. This horizon is a dynamic edge, expanding over time as light from more distant regions gradually reaches us. So why does the cosmic light horizon matter? It's because it represents the ultimate limit of what we can ever hope to see or know about the universe. Beyond this horizon lies a realm forever hidden from our view, as the light from those regions hasn't had enough time to reach us, traveling through the vastness of space. Picture the universe as a grand stage, with the cosmic light horizon as the curtain beyond which lies an unseen and unknowable expanse. The implications of this boundary are profound. It means that even as our technology advances and telescopes grow more powerful, there will always be parts of the universe that remain beyond our reach. This limitation challenges us to rethink our place in the cosmos, reminding us of the vast mysteries that lie just out of sight. The cosmic light horizon is not just a boundary of distance, but a frontier of discovery that fuels our curiosity and pushes us to explore the known universe with even greater passion. Each glimpse we gain from this horizon provides a snapshot of the universe's past, offering clues about its evolution and structure. As we continue our quest to understand the universe, the cosmic light horizon stands as a testament to the boundless wonder and the enduring mystery of the cosmos, reminding us that there is always more to explore, more to learn, and more to imagine beyond what our eyes can see. The universe has no center. Imagine that for a moment. In a universe so vast, it's easy to think there must be a central point, a cosmic heart where everything began. Yet the truth is far more intriguing. The universe is isotropic, meaning it looks the same in every direction, with no single point acting as its epicenter. Picture the universe as an infinite balloon inflating, where every point on its surface is expanding away from every other point. This analogy captures the essence of an isotropic universe, where every spot can be perceived as the center, depending on your perspective. If you were to stand anywhere in the cosmos, you would observe galaxies moving away from you in all directions, just as someone positioned light years away would see the same. It's a humbling realization, emphasizing that while we may feel like the center of our universe, in reality, every galaxy, star, and planet shares this cosmic individuality. This concept challenges deeply held perceptions, urging us to appreciate the boundless and unbiased nature of the universe. The isotropic view underscores a fundamental truth that the universe is vast and ever-expanding without borders to define or limit it. It reminds us that we are all part of this cosmic dance, with each point in space offering its own unique vista, yet sharing in the grand, collective movement of the cosmos. Embracing this truth invites us to ponder our place among the stars and to marvel at the infinite possibilities that stretch out before us in every direction. Stars can rain down in stellar nurseries, those magical places where new stars are born from collapsing clouds of gas and dust. Picture these nurseries as vast cosmic gardens where stars begin their life journey. The process starts with enormous clouds of hydrogen and other elements spread across space. Over time, these clouds feel the gentle pull of gravity, causing them to contract and heat up. Imagine a dense fog gradually transforming into a brilliant star as the gas and dust condense under gravity's embrace. As the cloud collapses, it heats up, and the core temperature rises until nuclear fusion ignites, marking the birth of a new star. This transformation is like the universe's own alchemy, where raw materials are turned into shining stars. Each star formation is unique, influenced by the cloud size, composition, and surrounding environment. Some clouds may form single stars, while others give rise to entire star clusters, creating a dazzling array of stellar generations. Furthermore, stellar nurseries are often obscured by thick clouds, making them challenging to observe directly. Yet, with advanced telescopes, astronomers can peer through these veils and witness star formation in action. As these young stars mature, they often shed surrounding gas and dust, triggering the formation of even more stars. This cyclical process of birth and rebirth illustrates the universe's dynamic nature, where the end of one star's life contributes to the creation of new beginnings. Stellar nurseries are a testament to the universe's capacity for renewal and change, reminding us that in the vastness of space, the cycle of star formation is an ongoing drama that shapes the universe and fuels our quest to understand the cosmos. These heavenly rainstorms of stars showcase the beauty and creativity of the universe, inspiring us to watch the skies with wonder and awe. The universe can host life beyond Earth. Imagine the cosmos as a vast garden, teeming with potential for life in the most unexpected places. As our telescopes and space missions become more advanced, we are discovering that Earth is far from unique in its ability to support life. One of the most fascinating ideas in this cosmic quest is the concept of habitable zones, often referred to as the Goldilocks zone. Picture a planet orbiting a star where conditions are just right for liquid water to exist, not too hot and not too cold, creating an environment where life as we know it could thrive. Within these habitable zones, planets could offer the ideal conditions for the development and sustenance of life. As we scan the stars, we've identified thousands of exoplanets, some remarkably Earth-like and nestled within their stars' habitable zones. Think of each exoplanet as a potential oasis in the vast desert of space. These discoveries are incredibly exciting because they expand our understanding of the possibilities for life beyond our solar system. They challenge us to consider the wide range of environments where life might exist, from rocky worlds bathed in the light of distant stars to water-rich planets with vast oceans. Moreover, the diversity of exoplanets we've uncovered inspires endless curiosity about the types of life that might inhabit them. Could there be microbial life flourishing beneath a planet's icy surface, or perhaps more complex organisms swimming in alien seas? The possibilities are boundless. As we continue our exploration, each new exoplanet discovery fuels our imagination, encouraging us to dream of what kinds of life might share this universe with us. The universe's capacity to host life beyond Earth reminds us of its infinite potential and the endless mysteries that await our discovery. In our search for life in the cosmos, we are reminded of our shared connection to the universe, a profound unity that transcends the boundaries of our planet and ignites our desire to uncover the secrets of life beyond. The Drake equation and Fermi paradox offer intriguing lenses through which we explore the enigma of extraterrestrial civilizations. Picture the Drake equation as a cosmic formula, designed to estimate the number of advanced civilizations in our galaxy with which we might communicate. This equation considers factors like the rate of star formation, the fraction of stars with planets, the number of those planets that could host life, and the likelihood of intelligent life developing. Each factor is a piece of a celestial puzzle that, when assembled, shines light on our quest for cosmic companionship. Yet, despite its allure, the Drake equation is filled with uncertainties. It invites us to ponder how common life might be in the universe and whether we're alone or just one voice in a cosmic choir. Enter the Fermi paradox, which poses a simple yet profound question. If intelligent extraterrestrial life is probable, why haven't we encountered any evidence of it yet? Imagine standing in a crowded cosmic auditorium, expecting to hear a chorus of voices, yet all remain silent. This paradox has sparked countless theories. Some suggest that advanced civilizations might be too distant or rare, or that they have chosen not to communicate. Others propose that civilizations may not last long enough to reveal themselves, succumbing to technological or environmental challenges. The Fermi paradox challenges us to reflect on the very nature of intelligence and civilization. As we expand our search for life beyond Earth, we are reminded that the universe is vast and filled with mysteries yet to be unraveled. Together, the Drake equation and Fermi paradox inspire awe and curiosity, urging us to continue exploring the cosmos and to never stop asking the profound question, are we truly alone in the universe? These frameworks enrich our understanding, encouraging a quest that transcends science and delves into the philosophical, inviting us to ponder our place in the grand cosmic tapestry. As we step back from our journey through the cosmos, let's reflect on the 25 remarkable truths we have uncovered. Each revelation reminds us of the universe's vastness and the profound mysteries it holds. From the ever-expanding universe faster than the speed of light, to the wonders of black holes defying their darkness, and the multiverse theories that challenge our understanding of reality, our exploration has shattered perceptions and opened our minds to infinite possibilities. We've journeyed through the eerie quiet of cosmic voids, glimpsed the brilliance of superclusters, and marveled at the universe's ability to host life beyond Earth. These cosmic wonders inspire both awe and curiosity, urging us to delve deeper into the celestial unknown. The universe is not just a distant expanse of stars and galaxies. It is a living tapestry of creativity and transformation, inviting us to question our place within it. These truths enrich our understanding of existence, reminding us that we are part of something grander and more mysterious than we can imagine. As we continue to seek answers, let's embrace the wonder and beauty of the universe, sparking our imagination and igniting our desire to learn more. We invite you to share your thoughts and insights on these cosmic realities, contributing to a community eager to explore the mysteries of space. If this journey has sparked your interest, consider subscribing to our channel for more awe-inspiring cosmic adventures. Together, we'll continue to explore the universe's wonders and unravel its secrets one truth at a time. Thank you for joining us on this incredible voyage, and until next time, keep looking up at the stars with curiosity and wonder.